It's time once again for another cold front.
Today we'll be talking about space weather.
From the science behind what happens in space to the northern lights, we are here to break down the details.
The cold front starts right now.
Welcome to this week's episode of The Cold Front. I'm Sabrina Bates.
And I'm Joie Bettenhausen. This week's episode is all about space weather and the science behind it.
Space weather is not something you usually hear about on a day-to-day basis, which is why we want to focus on this topic.
Earlier this week, I went to the HARI Union with VUTV News Director Jessica Burns to ask students what they knew about space weather. Let's take a look. So we're here at HARI Union asking students if they know anything about space weather. Do you know anything about space weather?
I'm assuming that it's weather that happens in space.
No, I do not.
No, I don't. I can't. I mean, I might have heard of it, but I can't say I know what it is.
I do not.
No, I have no idea.
No.
Have you ever seen the northern lights?
No.
I have not.
Not in person. I've seen video recordings of them, and I know basically what they are. I've never seen them in person.
I've always wanted to, but I have not.
I've never seen them, but I've heard of them.
Yes, actually.
That's really cool. Where were you at?
Up in the northern part of Michigan.
We also sat down with meteorology professor Dr. Adam Stepanek about what exactly space weather is and if forecasters can actually predict it.
Also, he explains whether or not any big weather events have occurred with geomagnetic storms. Let's watch.
Well, space weather, we're really looking at what activity is going on in the sun, and then with the surrounding medium, we're looking at what type of particles are leaving the sun and traveling towards Earth. And as such, the big difference from weather is when we're looking at weather and talking about weather in its normal form, we're more interested in what's happening in terms of rain or clouds here on Earth. And in this respect, we're looking at effectively the sun in outer space. Well, auroras are going to be when you get a large number of charged particles in the space area traveling quickly towards Earth, and they're deflected most of the time by our magnetic field, but they can kind of curve in by the poles, and so more often than not the auroras will be visible up by the polar regions, but not all the way down here by Valparaiso. So if there's a really intense event, once in a while we can see them this far south, but it's not common. The main type of space weather that's going to impact Earth is going to be geomagnetic storms, and there are going to be some that are of a much higher class. It's kind of like if you think of earthquakes, the Richter scale, to where one level higher is actually tenfold higher. So yes, the more intense geomagnetic storms have the ability to impact GPS systems and other things on Earth. The main one would have been actually in 1989. It occurred in affected areas in Quebec in Canada. So we had a very intense coronal mass ejection, which is related to geomagnetic storming, and it basically within the span of about 2 minutes knocked out power to all of Quebec for about 12 hours. So it was in the middle of winter and it's cold up there, and this was quite an eye-opener to what space weather can do on Earth. Yes and no. It's not that predictable, but things like these coronal mass ejections, or CMEs, actually take some time from when they occur on the sun to make it to the Earth. So we do have a number of imagers that are watching space weather and helping us to determine if something's occurred and give us a little bit of warning here on Earth.
We're going to take a quick break, but when we come back, we're going to delve deeper into the science behind space weather.
Plus, we'll introduce our new assistant weather director for next year as she provides insight to this topic.
Stay tuned.
What is passion? At Valpo, it's something that pours out of us uncontrollably. It's a late night shot of caffeine, cramming for finals, a jam session with friends. It sees deep into space, turns big stuff into small potatoes, floats boats and floods the senses. Passion is alive, it has a heartbeat, and it lives in you. How do we know? Because at Valpo, passion is who we are.
In a world where entertainment is at risk, one man is given a mission, but he is about to face his biggest challenge yet. He will race against the clock and open doors to new possibilities. that will save weekends as we know it.
What are you doing?
I'm looking for free movies.
Oh, I'll help you with that.
Just go to movies.valpo.edu. They have all the best movies, including The Hobbit and 22 Jump Street.
Whoa, it's that easy?
It's that easy.
Grab some popcorn, grab some buddies, and watch movies.valpo.edu's great selection.
Welcome back to the cold front. Many people travel toward the Arctic Circle throughout the year to see one spectacular thing in the sky, the Northern Lights. Most of us are only lucky enough to see pictures of them, but do you know really what they are? Meteorologist Sabrina Bates is at the wall to explain how the auroras begin, all starting at the sun. Sabrina?
Thanks, Joie. So we're going to go over everything that happens in space that relates to space weather. First, I'd like to say that all of these pictures are from Dr. Adam Stepanek. He's the one who helped me find all of them. So first, we're going to be starting with the sun. These are all the layers of it. I know we usually just see it as that little bit of ball of yellow in the sky, but there's actually a lot more to it. So we have the photosphere here, which is actually the coolest layer of the sun. You see these little dark spots? Those are sunspots, and I'll be talking about those in just a second. But we also have the chromosphere and the corona around it. That's that little bit of those rays that come out that you actually see when people draw photos of the sun. But that's also what you see when you have a total solar eclipse. That's that outer ring around it. Now, as I mentioned, we have those sunspots. This is an actual photo of sunspots on the sun. They're the darker parts that are on the sun. These are all actually localized magnetic fields that are on the sun that we can actually see. These are coronal mass ejections, CMEs. Now this isn't something that we normally see as we would see the sun or stars, so it's actually pretty neat to look at. These are actual photos in space. This is plasma that is actually moving away from the corona. It's just exploding. It's like a burst of energy off of the sun. Now those CMEs and solar flares all are part of the space weather along with the solar wind here. Now the solar wind causes the aurora borealis, which is all what we normally know. Here's an example of it. We have the sun right here with the corona and the CME that's exploding the plasma off of the sun, and also some of that solar wind. Now we have Earth over here. This is Earth's magnetic field. Now normally Earth's magnetic field will be able to deflect any of those solar flares or CMEs that come closer to the sun. But sometimes they able to get through it, and we have those geomagnetic storms in the aurora borealis. Here's an example from the Space Weather Prediction Center of what we usually look for when we are looking for larger geomagnetic storms. Now this is from today, so we don't have anything major going on. Usually when we have the green or the less than 4 for the K index, that's where we are safe. We don't really have any major geomagnetic storms. When we get closer to the yellows or even greater than red, that's when we have the greater geomagnetic storms. Here's an example of what all the qualifications are for those larger geomagnetic storms. It's kind of like a Richter scale or an EF scale where you have the enhanced Fujita, how you rank all the different tornadoes or earthquakes, but this is to rate the level of the geomagnetic storms. We have minor ones all the way up to extreme. If you take a look at it, it's a lot of words, but it's what happens to the power systems, the spacecraft operations, a ton of different things that actually happen on Earth because of these CMEs, these solar flares, and because of the CMEs, solar flares, and solar wind, we have a lot going on Earth, and we have the aurora borealis. And that's what we have Will here to talk about with, because you're really into the Northern Lights.
Yes.
So what really got you interested in all of that?
The first time I saw the Northern Lights, God, I had to be about elementary school.
Wow.
I was with my dad actually up in the UP, on the Upper Peninsula of Michigan, and we were out looking at some storms on the horizon, and just above the storms, we actually saw some green tint in the sky, and I asked my dad, what was that? And he's like, that's the Northern Lights. I'm like, wow, that's amazing. So that was my first time seeing the Northern Lights, and then I think from there it kind of just grew as a fascination as to why that occurred and just trying to capture those in a photo.
Wow.
So what do you look for in terms of, okay, I'm going to go out today, I'm going to go try and find these Northern Lights?
So there are multiple things that go into trying to find or see if you're going to be able to see the Northern Lights. A lot of times I go to the space weather page, and they have a bunch of graphs that I go through and I read the different variables on it. One of those would be the BZ value and a BT value. Those two values tend to tell you what the strength of the energy waves coming from the Earth are going to be. And if you have those parameters that are high enough, it'll then mean you could possibly see them in those areas. Another thing, or a common thing people look for, are the KP values. KP value generally around 5 or 6 or higher in this general area is good for seeing the northern lights. If you're up in the polar regions, you can have KP values in the 1, 2s, and 3s, and you're generally be pretty fine with seeing those. So that's some of the stuff I look for. Obviously, then also weather-wise, clear skies are great. Trying to get out in the middle of nowhere where there's no light pollution is also another huge thing. A lot of times I also will try to go to the dunes. I mean, the nearest thing you have light-wise is either Chicago to your west or Michigan City to your east. So when you're looking straight north on the lake, it's perfect. It's completely black.
So have you actually seen northern lights at the dunes?
Yes, I've gone, in my 3 years here, I've gone out to the dunes, I think, 4 times. Of those 4 times, I believe we saw them 2 or 3 times.
Oh, wow.
They were very faint, just on the horizon. But we did see them. Wasn't with our naked eye, unfortunately, though. We had to have a camera to see it. But then I saw them. I've seen them at my house before. Very faint on the horizon. But then when the UP, I was up there 1 or 2 summers ago with a few fellow classmates, and we happened to be surprised by a Northern Lights event that had just managed to happen over the lake. We were out just taking some long exposure night photography stuff of the stars and the skies and stuff, and I looked at one of my photos and I realized that there was a green tint to it, and I'm like, wait a minute. And I asked my buddy Cameron Nixon, and he's like, that looks like bioluminescence, which is just a natural phenomenon that can sometimes happen in your photos. So we ended up turning our cameras north on the lake and ended up picking up the northern lights, and we were probably photographing those for another hour, 2 hours, and they ended up being strong enough to where we could actually faintly see them again on the horizon, and we even saw some light pillars.
Wow.
Which is where you have streaks, really bright streaks of light from the northern lights in the photos, which was pretty cool.
Yeah, that's really cool.
Yeah, that's really awesome. Did you notice, like, when did you exactly go to the dunes? Like, around what months? Is there a certain season to see them, or?
There's not necessarily a certain season.
Okay.
Overall, in the general scheme of things, we have solar minimums and solar maximums. Right now, we're technically in a solar minimum. It's about an 11-year cycle, I believe is what it is. So we're actually in the solar minimum now. So technically speaking, it's not the best time to see them, but they've actually found, the scientists have, that even in solar minimums, you tend to have these small little episodes where you could have spikes in activity.
Okay.
So there wasn't really a specific season for it. We've gone in late November, we've gone in the spring. The best time, though, to really see it, for at least in these cases, was after about 10 o'clock. So between 10 p.m. and about 3 a.m.
Okay.
I think the latest we were there was like 4 a.m. and then I had to go to a Met class at 8 in the morning. So that was a rough night.
It was worth it, though, right?
Yeah, it was extremely worth it. I wish my photos turned out a little bit better. They were a little out of focus, but my bud Cameron got some amazing photos, and I wish I had those great photos to see.
That's so amazing. So when you see these northern lights, do you usually like look at it a few days in advance, or is it just like that day? All right, I know it's going to happen. Let's go.
So the way the forecasts work, depending on what kind of solar storm or event occurred, you can get sometimes a 3-day heads up that there might be some solar activity from this time to this time. Other times, if it's a really strong storm, for instance, you might only have 48 hours. The best you can do is usually a few hours before it. The graphs that you can look at for the KP values will give you a rough idea of what it was previously, and based off those graphs, you can then assume it might be like this. So I mean, there's not exact science to it. I wish there was more we could understand. The new satellites we have out are supposed to help study this stuff and get us better measurements, but it's still a science that is really new.
Right.
Well, it's very fascinating.
It is. Thank you so much for joining us, Will.
No
We really do appreciate your expertise, especially on this field.
Right, and if anyone has any questions about northern lights, we know that we can send them straight to you.
Right.
Exactly. Well, yeah, thank you again. So we're going to take another commercial break, but when we come back, we introduce our new assistant weather director.
Well, I think that's all we need. Thank you so much for coming in. We'll be in touch.
Okay, this is it. Just shake his hand and walk out with your head held high. Don't mess this up. Thank you. Nailed it. Don't let a bad handshake get in the way of getting the job you want. Find out more at the Career Center.
Thanks for sticking with us.
We are joined by the new Assistant Weather Director for the 2018-2019 school year, Heather Bricka.
So thank you for joining us, Heather. We're so happy that you're here
Yes.
with us, so everyone gets to meet you. So if you could just tell us where you're from, why you came to Valpo, all that.
I'm from Coeur d'Alene, Idaho, and I came to Valpo for the meteorology program here.
Okay, so what are you exactly interested in meteorology?
I'm more interested on the broadcast side of things, so that's why I'm involved in VUTV.
Okay, so what got you interested in weather? I know that's a question that everyone asks us meteorologists or those studying it, but what got you interested in it?
I never really saw a lot of storms growing up in California, so I used to watch the nightly weather with a woman named Heather, and she would always talk about weather, and it got me interested, and maybe I could do that for a real job. So ever since I was 5, I wanted to be Heather with the weather, and I always told people that, and that's kind of been my tagline.
All right.
No, that's really awesome. So obviously you're the new Assistant Weather Director for next year. Do you have any hopes or goals that you want to accomplish for next year?
I'm just really excited to see what this position will bring and kind of helping educate the other Valparaiso students on meteorology and broadcast as a whole.
All right, well, we're so happy that you're here with us, so everyone gets to meet you.
Yes.
So now what we're going to do is start talking about the effects that geomagnetic storms have for those of us on Earth.
Right. Now, not only are there effects on, you think, satellites and equipment, but also some health effects as well. So first, we're going to dive into this first article here. It is by health.com, and it does quote NASA in a few of its wordings here. And it talks about mainly solar flares and how, the burst of radiation, it doesn't really affect us, which I know is contradictory for the next article, which we will get to in a second. But yeah, it says that even though there are those powerful bursts, lots of radiation, that it won't actually pass through the Earth's atmosphere.
Right, and those of us who actually are affected by it, it's going to be those, as the article says, who are more sickly or not in as good of health. It's not going to be those who are very healthy people. They actually have a study that they quote in this article. They say, beginning of the quote, a 2014 study published in the journal Stroke found a link between geothermal storms and stroke risk among people in New Zealand, Australia, the United Kingdom, France, and Sweden. So the study compared 11,453 hospital reports with the daily geomagnetic activity. Now that's going to be stronger geomagnetic activity over a 23-year period, and found that geomagnetic storms were associated with a 19% increased risk of stroke overall and a 27% increased risk among adults under 65, end quote. So there is still a decent amount of people that the study have found that have seen more of an increased risk of having these health complications.
Yeah.
But it usually does not affect people.
No. Yeah, it usually doesn't. And I know they kind of mentioned here that they may be a different way of approaching the geomagnetic storms and when they're going to actually occur with announcing them with weather forecasts. That way people know they're coming, and that might decrease the risk of stroke.
Right.
And they also said that it's more of the solar flares that cause the concern for most people because they see those coming in and they kind of get scared.
Right.
But it really only affects the radiation and kind of the transformers, which will cause power outages around the world.
Right, that's going to be the biggest thing when you have those solar flares coming in. They're going to directly impact, especially like you said, telecommunications, those power outages, all of those grids. So a lot of people actually could end up without power if you have a strong enough geomagnetic storm.
Right, and just think about satellites as well. You have, your GPS and your different communications. So if you knock out the GPS, that's, for individualized purposes if you're driving somewhere, or with planes, and even different communications within that. So that could really just even damage a lot of industry as well.
Right, it's definitely interesting because airplanes with their certain paths, there are some paths that actually cross over the North Pole. They'll go from one side of the pole to the other within the Arctic Circle. But if there's going to be a strong geomagnetic storm, they actually divert those paths because they don't want those planes going over those regions where they're going to be majorly affected.
Right, because that could definitely cause a lot of damage, especially for the passengers and pilots, just having exposure to all of that radiation, even though they're so high up there.
Right. Now, since we're talking about closer to the poles, we're also going to briefly mention the northern lights. I know that's something that most people actually know when we talk about space weather, anything with that, because it's something that we actually can see with our own eyes.
Right, so I know this article here by space.com, it mentions to go between December and April because it's less cloudy, because obviously if you have clouds you can't really see the northern lights, and just to make sure it's a clear day. It also mentions that between 10 p.m. and 2 a.m. local time is the best time to actually see this. So definitely dress warm, especially in these winter months, but I've definitely never seen these before, so it'd be cool to see.
Right, definitely need to get closer to those poles, closer to the Arctic Circle, because that's where it's going to actually be the strongest. And you want to go when it's dark outside, obviously. You don't want to be going when it's the middle of the day, because I know once you get into those closer northern areas, you're going to be seeing more daylight hours throughout the entire day.
Especially in Idaho, we had Aurora Borealis that came through just last year, and everybody set up their cameras and went out and tried to get a good shot, and the only one good shot was like 2 hours away from home for us, but we stayed up till like 3 a.m. trying to see the Aurora Borealis.
Yeah, no, it's definitely awesome, and also moving away from the city lights, especially, you know, being out in the country, different things like that. That way, you have nothing really polluting that view.
Right,
I think that's very true.
I think the northern lights are just something that everyone always wants to see. It's always on someone's bucket list, as you would say.
Yeah, but there's also like the northern lights, but the Aurora Australis is also a thing, which is south as well. Yes. And those are more like pink lights. But the northern lights are more of the green and blue hues that you'll see up north.
It's very interesting to see the different colors. It also do with the different oxygen and all the different
the different gases within the
atmosphere.
And I know that can definitely change the variation of exactly what colors you see or how they're scattered across the sky.
Right, it's definitely a very interesting topic.
Yes.
All right, well, thank you so much, Heather, for joining us talking about this. We're excited to see what you do this next year.
Yes, thank you so much.
Well, that just about does it for another episode of The Cold Front. Our final episode will be in 2 weeks. Follow us at VUTV Weather on Facebook for the latest weather updates.
Also stay up to date on the latest news here on campus and around the country by following VUTV on Facebook, Twitter, and YouTube.
I'm Joy.
And I'm Sabrina. Have a great week, Valpo.